All right, in this video, we're going to look at error analysis, the full analysis of errors. The term error is used to describe the uncertainty associated with a calculation or a measurement. So we're talking about uncertainties associated with a calculation or a measurement. Now we have to introduce some terms here. And the first is the term error. Error is simply the difference between a measured value or calculated value and the actual value. So the term error simply tells us the difference between our measured value. So it is an absolute value here, measured value, minus the actual value. The measured value minus the actual value, the absolute value of this. So it can either be positive or negative. For example, if the measured value is less than the actual value, then we get a negative answer for the error. And if we have the measured value being greater than the actual value, then we have a positive value for the error. So we're taking the absolute value as the error. We can also have the calculated value. So or error can also be equal to the calculated value, the result of the computation, the result obtained from a calculation, the difference between that result and the actual or true value. The actual or true value gives us the error. Now, it is common practice to express the error in terms of the actual value. So we have two terms for that, the relative error and the percentage error. Let us take a look at that also. So I'm going to have to take these traces away. So let's see, we have these two terms. The first is the relative error. Relative error. The relative error is simply the fraction of the actual value. Fraction of the actual value. So we have the actual error. And we divide by the actual or the true value. Yes. I can simply write the error in the numerator. So let me take that away. I can simply write just the error, and that works. The value of the error, which we described earlier, simply divided by the true or the actual value gives us the relative error. Now, to find a percentage error, we simply express the relative error as a percentage. So percentage error is the relative error expressed as a percentage, which means relative error, which is the actual error, divided by the true value, multiplied by 100, gives us the percentage error. All right, so let us get into illustrative examples now, using this concept. All right, and for that, I have to take the traces away. That's right. So let's get into it. The length of a playground is 100 meters. If the measurement of the length was recorded as 98 meters, determine the relative error and the percentage error. Let's go for this. So first, I like to take on the relative error. And now we know the actual value is 100, and then the measured value is 98. So let's take on the actual length, which is the actual value. The actual length of the playground is 100 meters. We have it. And that's it. Now we have the measurement, the result of the measurement. So the measured value is 98 meters. And you can see there is already error incurred. Now let us do the actual error. The error is an absolute value here. So we want the positive value. Because we want the positive value, we simply take the difference between the actual length and the measured length, which means we have 100 minus 98 in meters. And this gives us 2 meters as the error. With this, we can now solve the question. So the relative error. We know the formula for the relative error. The relative error is the actual error. Simply, I like to write error divided by the true value, which is the actual length. That's the relative error. And if we may continue along that path, we have the relative error is going to be the actual error, which is 2 meters, divided by the actual length, which is 100. And that means the relative error is simply 0.02 in decimal form. Our final answer for the first question. Very simple. Beautiful. And by multiplying this by 100, we can have the percentage error, which is the second question. So we can say the percent error is simply the relative error multiplied by 100. So we have 0.02 multiplied by 100. And that certainly gives us 2%. Our final answer. Very simple. Very, very simple indeed. All right, let's move on to the second question. Right, for this, I'm taking the cases away. So we have, in this question, 20 grams of salt was weighed by Brian as 19.8 grams. What is the percentage error in his measurement? Let's go for it. 20 grams of salt was weighed by Brian. So that is the wrong measurement, 19.8 grams. The actual mass of salt, 20.0 grams. So we calculate these details in our solution. Actual mass of salt. Actual mass of salt is 20.0 grams. Now we have the measured value. The measured value of the salt as 19.8 grams. 19.8 grams. All right. And now we can take the actual error. So the error involved is the difference between these two values. The error is the difference between these values. It's an absolute value. So let us take on the bigger value, 20.0, minus the smaller value, 19.8 in grams. And this gives us, by subtraction, 0.2 grams. This is the error. Now we can find the percent error. From our formula, the percent error is the actual error divided by the true value, which is the actual mass in this case. The actual mass in this case multiplied by 100. And now we can have the error, which is 0.2, as you can see. We have it right there. 0.2. All right. And the actual value is also known, 20.0. So we can make use of these values right away. And now the percent error will be the error value, 0.2, divided by the actual mass, which is 20.0. I will simply write 20, multiplied by 100. And this can easily be calculated. 0, the giveaway, 2 checks, divides into 10, 5 times. And 0.2 multiplied by 5 gives us 1%, 1.0%, respecting the fact that values are presented to one decimal place. 1.0%, our final answer. Very simple. Let's move on. We'll take on the next question. Now, in this area, we're going into percentage errors due to independent measurements. Percentage errors due to independent measurements. Now, in this case, we're looking at measurements involving different parameters. Supposing we have a parameter P described by an algebraic relationship K with a value A to the power X, another value B to the power Y. And we have this relationship. K is a constant in the expression. A and B are variables that determine the value of P. All right. So P is the dependent variable, depends on the values of A and B, while A and B are the independent variables. K, X, and Y are all constants. Now, we can easily show, using the knowledge of calculus that will be presented much later in my videos, we can show that the percentage error in P can be calculated. Since K is a constant value, we do not involve K in the determination of the percent errors. But now the variables, the constant values X and Y are associated with the measurements of A and B. So we can show that we have X multiplied by the percentage error in A. And we add this to Y multiplying the percentage error in B. Now this expression is very useful when we want to estimate quickly the percentage error due to independent measurements. You can see the error in P is determined by the errors in A and B with the participation of the powers of the exponent X and Y. K is not involved. Beautiful. So it is important to note this. Let us share another case. So please note this. I have to take this trace away so that we can share another case. The cumulative nature of error. Supposing I have another parameter, W, being equal to a constant K, once again, with variables A to the power X, B to the power Y, divided by C to the power Z. All right, and we have this. We can also show, using the knowledge of calculus, that the percentage error in W is simply, there is the cumulative nature of error here. K doesn't participate, so we have X multiplied by the percentage error in A, added to Y, multiplied by the percentage error in B, Y multiplied by the percentage error in B. And now cumulative nature of error plays a part here. We do not recognize the fact that C is in the denominator. That is not a factor here. We're still going to add. So we have plus Z, the power on C, multiplied by the percentage error in C. Beautiful. So this is another relationship. Now let us put this into practice. So cumulative nature of error, despite the fact that C is a denominator, we do not subtract, we continue to add the errors. Cumulative nature of error, that's what this is for. Right, come with me. We're looking at illustrative examples right now. I'm taking the traces away. Right. Okay, let's put it into practice. All right. If the percentage error in the radius of a circle is 3%, find the percentage error in the area of the circle. Here, our knowledge of mensuration must be called. Our knowledge of mensuration straight away. So I start straight up by saying the percentage error in the radius of the circle is 3%. That's noted here. So we have the area of the circle. Area of the circle is given by A and is equal to pi r squared, where r is the radius of the circle. Pi is a constant, 22 divided by 7, or 3.14. It is a constant. And therefore, by applying our relationship, we know the percentage error in A. Percentage error in A is simply, pi is a constant, will not participate, as we have already studied. Yes, the pi will not participate, of course. But we have the exponents coming into play. So 2 down, multiplied by the percentage error in R. That's right. And now we're already given the percentage error in R. We have it already. The percentage error in R is already given to us as that value, 3%, and we can introduce it right in there. So we have, therefore, the percentage error in A is going to give us 2 multiplied by the percentage error in R, which is actually given to us as 3. And we have, therefore, the final analysis, the percentage error in the area of the circle is equal to 2 multiplied by 3, and that is 6%. Our final answer. Very simple. This is very simple. So let us see another application of it. All right. Okay, here we are. Another question. I'm going to take this away. Yes. The radius of the circle is given as 5 centimeters, subject to an error of 2 centimeters. That's right. What is the percentage error in the area of the circle? Similar to the previous question. We have to settle down to calculate the percentage error in the radius. So we start straight off by saying the percentage error in the radius. We already know the value of the radius, 5 centimeters, and it is subject to an error of 2 centimeters. So we can find the percentage error in the radius. Percentage error in the radius, R, is given by the error is subject to an error of 2 centimeters. So we have 2 divided by actual value of the radius, that is 5, now multiplied by 100 to express as a percentage. And we can evaluate this very quickly. 5 can divide through, 5 check. 5 divides into 10, that's 2 times. 5 divides into 0, that's 20 times. And that means the percent error in this measurement is actually 40%. That's massive. 40%, that's massive. Now we can find the percentage error in the area of the circle. Now, to do that, we need to establish the formula for the area of the circle. The area of the circle is given by pi r squared, as we have learned, where pi is a constant. And therefore, we can write our relationship in terms of percentage error. Percentage error in A, the area of the circle, is simply pi being constant, will not be taken into consideration. So we have to multiply by the percentage error in R. And that means we're going to have, therefore, the percent error in A is going to be, let's substitute our values, to multiply by the percentage error in the radius, which is 40. And by multiplying this, we have 80% as our final answer, which means this measurement was really awful measurement, 80% error. That's much. Let us look at the next question. All right. Now, the traces we have to give way here. Percentage errors of 2% and 3% respectively occurred in the measurement of the radius and the height of a cylinder. Find the percentage error in the volume of the cylinder. Now, the formula for the volume of the cylinder must be called up. So let's get into it. The percentage error in the volume of the cylinder. Let us call upon the volume of the cylinder. So we have from the volume of the cylinder, V is equal to pi r squared h. So you see that the formula for these shapes, the mensuration must be borne in mind. So we can easily call upon each of them. Percentage error of 2% in the radius, 3% in the height, as we have seen. But let's go. Our relationship says the percentage error in V is equal to pi being constant, will not be taken into account here. So we have to look at other variables that are relevant. So let's go. 2 multiply by the percentage error in the radius, multiply by the percent error in the radius, added to, and the exponent here is 1. So we can say simply the percentage error in H, the height of the cylinder. These values are given already, so we can finish it off. And this is going to give us 2 multiplied by the percent error in R, which we know clearly from the question. Percentage error in R is simply 2%. So let us introduce it, multiply by 2% right there. Then plus percent error in H, which is also known, and that's the percent error in H, 3%. We have it. So let's introduce it right away. 3. And now we're going to evaluate this to get 2 multiplied by 2, that's 4, plus 3. And now we have percent error in the volume, clearly, 7%. Our final answer. Very, very simple. All right. And this is very beautiful. That's great. Right. Now it is important we take these steps right now. If you have not already subscribed to this channel, please subscribe to this channel and turn on the notification bell so that you can have an alert when I release videos of this type. These videos are very instructive. So please subscribe to this channel, like the video, and share with friends. All right. Now it is your turn to practice. As you already know, practice is the only way to expertise. It's the only way you can become an expert. Mastery and expertise are actually products of persistence and consistency in practice. That's one of my quotes. All right. So are you ready? Are you ready for your practice? Let's go. All right. So you can pause the video to take these questions. The first one, 10 grams of salt was weighed by Jenny as 9.8 grams. What is the percentage error in the measurement? The radius of a sphere is given as 5 centimeters, subject to an error of 0.2 centimeters. What is the percentage error in the volume of the sphere? So please do these calculations. Only when you have solved, you can look at the answers. If you have any questions, let me know in the comment section so that I can attend to them. Because answers to your question will be given within a few minutes once you send the questions. Thank you for watching. Please subscribe to this channel once again and follow me on these platforms, YouTube or Facebook, Instagram, TikTok, on chess.com to learn chess, and on Instagram. You can send me a WhatsApp message. You can check me on Amazon, Temple AK, and look at some of my publications. And of course, you can send me an email. Thank you for being part of this session. I'm your special coach, and my name is Temple AK. See you in my next video. Bye-bye for now.